Hello and welcome to SudoKanard. We're here to solve this big band Sudoku that was created by said Holaysan from the Philippines. And this is meant as a practice puzzle for the upcoming WPF Sudoku Grand Prix, where there will be a big band Sudoku with lots of points, I think something like 66, I guess. So the special rule here is that you have those big bands, and you must input each of them in one of those places. So those are a 7-digit string, and you must place one of each in one of the two directions, and that's it. So where can we start? Well, there are restrictions. There are two types of restrictions on such a puzzle, which is that every band has two orientations, but the middle is always the same. So right from the get-go, we can pencil mark the centers of those bands. They are from 1, 2, 3, 5. That's not necessarily the best of things to pencil mark them so brutally, I should say. But this is something that can be done. Something else of interest is this big line here must contain 5 different digits. So it will be this, because 4 is repeated, here 6 is repeated, this could work, this could work, this could work. So actually this at the center is not a 5. But then, where else can we look? This 4 here puts some restrictions, I think. Well, there are not that many 4s. Perhaps we can see if there are digits missing. No, all digits are present somewhere on those bands. So where is another place to look? We can see, however, that on all ends of those lists, we never have an 8 or a 9. So we don't have 8s or 9s in those positions. I'm not sure that it matters that much. Well, actually, this could have an 8 or a 9. So that doesn't seem very easy, to be honest. So this 4 could be useful. So we know that this 4 at the end is not here. Those 4s next to the end are not here. Not here. But that seems to leave lots of options anyway. So what else can we see? We have ends that see each other in here. So we must avoid conflicts between those values. Not really not seeing what I should say. Perhaps I should try some of them. Or perhaps, oh, here I also need 5 different digits, and here as well. Yes, that's it. So I was focused at the beginning on those digits being on the same row, so they must all be different, but here the 5 digits must also be different, and here as well. So those 3 bands are the bands at the bottom, which means that those centers are not 5s, but those are 5s. So we know that those bands are those ones actually, and they all have 1 and 3 on their ends. So this is 1 or 3. This is a 1 of 3 pair, and because of that, this is now a 2. Beautiful. So this at the middle is this band here. So 2 has 1 and 9 beside it. Those are a 7-8 pair. And the remaining ends here are a 2-6 pair. So this is good progress. And here we must have 3, 4, 5, and 6. And obviously, this is not a 4 because of that. Now, what can we see? Those 5s are surrounded by either 4 and 6 or 6 and 7. So those digits are from 4, 6, and 7. And this digit here is not a 4. And something else of interest is that one of them is a 6 and one of them is a 6. And 1 and 3 are surrounded by 2, 8 or 5, 8. So those digits here are from 2, 5, and 8. And we can see that because of those 5s, we can remove options. So there's a 5 in here somewhere. And then, what are the ends of 1 and 3? So the ends that appear here are the ends of this and that, which means 1, 4, 7, or 5. And that's interesting because those are not 4s, so they must be from 1, 5, and 7. One of them here has to be a 4. That's not saying so much. And about those digits here, they must be from those. So 4, 6, or 9. And this here is obviously not a 4, and this is also not a 4. I didn't do the same with those bands, the bands with the 5s. So the digits in those cells are from 3, 4, 6, and 8. This is not nice pencil marking, but let's do it anyway. 3, 4, 6, 8. Now, because of this is never a 4. But this is both cells here, and we know that one end is 1, the other is 3, so this is never a 3 either. And actually there is a 1, 3 pair here, so we can remove 3 here. The same happens there, so we can remove 3s there. And then, so here, this is from 6, 7, or 8. There's a lot of rain outside. I'm wondering if you can hear it. It hasn't rained for weeks in my region. So this is some kind of relief, or so I hope. Let's focus on the puzzle. So we know that both 5s are surrounded with a 6. So there is definitely a 6 in here. There is a 6 in here. I'm not sure it was wise to pencil mark so much, but I'm really not seeing what else to do. There seems to be some kind of restriction on 6s, actually. So those are 5s, yes. So one of them here as an 8. So where is the next place to look? This is really, really difficult. Is there anything interesting with those? Definitely there is. This is different from that, and this is different from that. So those are the same. So those here are different. And that's interesting because here we have a 1-3 pair, and this cell sees both, so this cell can't contain a 1. And the same is happening here. This cell here is the end of this or that, and it can't be 1, so it has to be 4, 5, or 7. So now, this one here is either this one, if this is a 1, or this one, if this is a 1. So we have a 1 in only one of those two, and actually only one because there is a 1 here. So we have ones there or ones there. This is a mind-bending geometry. I'm not seeing where else to look. How will we disambiguate? Actually, this 4 is the only tool to disambiguate the bands, well, the shaded cells that are given are completely symmetrical. So this 4 is the only disambiguator. So it will really come into play. This is actually what will put this 4 somewhere. And this 4, really, because of this. Yes, that's true. And this 4 as well. So I'm really not seeing what to do next. Perhaps I should do some coloring. So let's say that this with the 1 and this with the 3 are green. This is obviously something I won't be able to do during the contest. And let's say we use orange for the 5s. So it will be easier to look at where we are supposed to look. So what are those pairs? One of them is a 3 and 4. No, we're looking at 5s, yes. So, oh, this is what I've been missing. Yes, on those two, somewhere here we have a 3 and 4, and the other is a 6 and 8. And obviously this is not a 3 and 4. So this is the 6, 8. And this is the 3, 4. So that's the 4, that's the 3. And that's the 1, and that's the 3. So this is a real progress. So with this, that's a 1. And that's a 3. And that's a 3. And that's a 1. So this here is actually this one. So I could use some other colorings. So surrounding the 1 are 2 and 8. And then we have a 6 and a 9. So that's not a 4. And then we have a 1 and a 4. So this is the 1 and this is the 4. So this 4 really helped us disambiguate. So 1, 6, 2. So that's the 6. That's the 2. That's the 8, and that's the 9. Perhaps I should watch if my battery is good at this point still. So on this row, 4 goes there. and on this. So we have the 6 and 8, and this is 6 or 7. Here we have 1, 3. This is this one. 1, 3, 4, 5, 6, which makes this a 5. And then this 3 here makes this a 6, so that's a 3. And what about this 3? The 3 here is surrounded by 5 and 8, so this is the 5, this is the 8, so this is 3, 8, 6, and 5. And on the other end, 4 and 7. Now this 7 disambiguates that. That's a 6 and an 8. That's a 6 and a 7. Is this part disambiguated yet? Yes, this 6 makes this a 2. So starting from this 2, this is 7, this is 9, this is 1, this is 8, this is 6. So the rest should be plain Sudoku, and I hope it will be easy. So with this 8 and this 8, we get this 8 here. 1 and 2, 1 and 2. Well, I'm tempted to just pencil mark like crazy, but actually, looking at those digits, this has to be a 7. We need an 8 and a 9 in the column. Here, this is not a 3. This 5 here goes there. So that's 3 and 4. Here I need 7. I need a 3, so it's here. 7 and 9, because there's this 7 at the bottom. Here 1, 8, and 9, so this can only be a 1. Here 2, 3, and 7, so 3 is at the bottom. 2, 7 there, 1 doesn't go here, so that's a 1, that's 8 or 9. Here I need 1, 2, and 9, so the 9 can only be here. This is 1 and 2, and this is 5. Here I need a 2, it's here, that's a 4, that's also a 4. Here I need 2, 7, and 9, so the 2 can only be here. That's a 7, that's a 9. It disambiguates the 8s and the, and the 9s. At the bottom I need 1, 2, and 6, so this is 1 or 2. Oh, this is actually a 9. 1, 2, and 5, so 5 is here. This is 1 or 2. Actually, there's a 1 here, so that's the 2, that's the 1, that's the 2, that's the 1. Here I need 3, 5, and 6, so that's 3, that's 5, that's 6. And now 7 and 8, that's 8. This is 6. This is 9, I think. That's a 2. No. What did I do? I need a 5 in this box. What did I do here? This should have been a 7. So this is now a 5. Oh, that's some recovery. So very well constructed puzzle with this disambiguation in the end. And I think I didn't stray too far away from the intended solve. I just lost some time not seeing this part. I think that was the part with the 8, 6 and the 3, 4. I had relied too much on something global without thinking which one is with which one, and the fact that in the geometry they were aligned on the same row. I think it's the first time I've been solving a puzzle by Seth Holaysan, and this is definitely something that should be fixed. Thanks for watching this video. I wish you the best for this Grand Prix round, and I see you soon on SudoKanard.